Hey guys, Timmy D with Mapping Affinity, and today we're going to run through Emlid Studio version 1 beta 10. So Emlid released the beta version of this software sometime in 2021, and so it is now up to beta version 10. I would anticipate that a final version will be released this year, but this software is really what I would consider a game changer for Emlid. When you do mapping or you're going out surveying, you always have to have access to doing PPK processing. And before Emlid came out with Emlid Studio, you either had to learn the RTK lib, which was very difficult. I'll admit I could never learn it. The other option was purchasing EasyServe. And there are probably some competitors to EasyServe that I'm unaware of. EasyServe is excellent software. Don't get me wrong. It is, it would probably be what I would consider the Cadillac of PPK processing, but it is also very expensive. And with Emlid releasing Emlid Studio, this is a game changer. You will be able to do PPK processing for just your general benchmark ground surveys, but you also can do PPK processing for your drone flights. So for any of you guys that have kits where you are putting the Emlid M or M Plus or M2 on a drone, say like a DJI Phantom 4 Pro, you now can use Emlid Studio to post-process that for PPK drone flights, and that is going to be very helpful. Now, in this first video, we are going to walk through, and I'm just going to show you the basics of Emlid Studio and how to process your base with your Rover doing ground control points. I will do a second video where we will cover doing the post-processing for your drone flights. Again, this software, in my opinion, is a game changer for Emlid because prior to having this available, it made it very difficult for new guys getting into the mapping business to be able to do post-processing. And so we're going to run through it. Hopefully this will be a short video. I actually did one. It was much too long. I rambled, which I sometimes tend to do. But we're going to run through this start to finish. I'm going to show you how to process, and then hopefully be beneficial, and we'll do another one for the drone processing. All right, let's get started. Okay, this is the project that I'm using to demonstrate this. And in this particular project, I did photogrammetry, did LiDAR. I set benchmarks here, one in the east side and one down on the south end. There were no existing benchmarks that were available. So I set these up, and this is often will be the case. You may be coming to a site that you're going to map, and you may want to come back multiple times. Maybe you just have a reason that you'll be coming back and reflying the site multiple times. And in that case, it is good to have a benchmark because now you can come in, you can set your Emlid base unit over the point that you establish as a benchmark, and then you will use your Rover to go out and take ground control points, or maybe you're just actually doing a survey of all the assets on the property, doing the parking lot, you name it. So that is the location and what we have set up here. So now let's go ahead and get into the Emlid Studio and run through that. Okay, so we are looking at the Emlid Studio screen, and I'm just going to quickly run through some of the settings. And this video, I should have mentioned this in the opening, this video is for guys that are brand new to Emlid and possibly just brand new to PPK processing. Your options in the past, again, have been RTK lib or using some other software. If you're a pro and already know all that stuff, you really don't need this video. But for guys that are new and you are now trying to learn how to do PPK processing, that's who this video is for, and hopefully it will be very helpful. So there are four options listed up at the top. You have PPK, and what that is going to be for is processing a static unit. If you go and set a base unit up, so let's say you have two RS units. It could be a RS, RS plus, or like what I have is the RS2, so that's a dual frequency. Your drone data, again, we're going to do this one on a separate video. Stop and go. So when you have a base unit set up and then you have your rover where you go around and survey your ground control points, this will be the functionality that we're going to use. Now, I will tell you, right now in beta, they do not have it set up to where you can just very easily bring in the CSV file if you use the web interface, so or what is considered the reach panel. So when you're using the RS units, you have the ability to log in to the unit directly. So when you set it up as a Wi-Fi hotspot, you know that you can log in and you can use the web interface, which is called the reach panel. I actually like using that. I do like the Reach View 3, but there are times when I use the reach panel. And when you do surveys, let's say you have a ground unit or a base unit and you're going to survey it. If you do that in the reach panel, the CSV data is saved directly onto the RS unit. When you use Reach View 3, your data is saved on the device that you're using. So if it's your iPhone, iPad, Android tablet, whatever you're using, it is saved on that device and it is not saved on the reach unit. Now the logs will be, but the actual file, the CSV file, will be on your device. And so for right now, the only thing that you can do is bring in a Reach View 3 CSV file, and we'll cover that. I do believe they're going to make modifications so that you can directly import a CSV from the reach panel or the CSV from Reach View 3. That's a tongue twister. So hopefully that makes sense. And there is a workaround. I'll do another quick short video on exporting out and then bringing it back in. But for right now, we're just going to run through. Okay, so the last one is just convert to Rhinex. If you needed to convert a file to Rhinex, that's your fourth option. It does this automatically if you bring in a uBlocks format. So let's go back up to PPK. Now, you've got your modes here. So if you are doing a fixed base unit that we need to process, that's going to be done as static. When you have a rover, typically that will be done in kinematic because you're moving around. So it'll be kinematic. And matter of fact, let's get me off the screen. When you are doing PPK processing, you always have to have two units. You're going to have a base unit and a rover unit. In the case of, I'll bring it back up. In the case of this right here, my base unit was here. The unit that I'm going to use for processing is a core station. So in the United States, there are core stations all over the country. In certain parts of the U.S., there are certainly many more core stations than other parts, but you still have access to core stations within a reasonable distance all over the United States. If you are outside the country, if you're in another country, India or wherever you may be using the Emlid unit, you most likely will have some core stations in your country. I have no earthly idea on looking up core stations, but once you know how to do that and pull the files in, all the processing is going to be the same. If you have access to 0 cores units, then you can do what is considered PPP processing to then establish a benchmark not using core stations, and that would even be another video that we could do later. But there's time involved with that. It's not something that's done quickly, but still, if you need to set up benchmarks and then have the ability to have your own local benchmark for your area, then that is something that can be done when you do not have access to core stations. All right, so going back, the first thing we're going to do is we're going to come in and I'm going to import. I have already exported out the log file and the CSV file for my RS2 rover. And I also have exported out the log files for my RS2 base unit. Okay, so I have the two folders for my base and my rover. And the first thing I'm going to do, and you're going to notice I've already, where I've processed this previously, I have the Opus results, because we're going to compare what Opus gave us as results compared to Emlid Studio Beta 10. I have the core station's data, but I'm going to show you where you go to find that. But the first thing we need to know is what date and how long of a log file do we need to download from the core station. So in my base files, I have the Rhinex format, and I'll mention this. In the Reach View options, when you are logging, you can log only as UBX, but if you choose to log as Rhinex, it will actually log both. It will do the Rhinex, and then you can pick which version of Rhinex, but it's actually going to save both of those in a zipped format. So that's what I do. And when you choose to do that, there's an option now to even save it for Opus, and then you can specify your antenna height, and that is then going to be in what is considered the header information for your Rhinex file. But what we need to find out is the date and the time frame for this log file so that we can download the log file from the core station that will encompass that. So I'm going to go in here, and when you open it up, you're going to have your observation file, which is O, and then your navigation file for peak. Think P for path, and that's your navigation file. So I'm going to take this observation file, but because we are processing the base unit, for the sake of processing in Beta 10, it's actually going to be the Rover, because it is the GNSS receiver that is being corrected. So the Rover is always what is being corrected. So I'm going to put it in here into Rover, and you can see that it specifies my antenna height was 1.803 meters, and then it also will add the offset, so it will apply the 0.134 offset to that. Now, what I hope is that in future versions, Emlid will just go ahead and have your date and time frame listed. There's plenty of space down here that can be utilized, so that once you import it in, it will just tell you and show you what that is. But what we will do is I'll click on the settings, and when you open up the settings window, when you're new to this, you think that this is all there is, because you do not see the scroll bar over on the side, and there's nothing to indicate scroll down. So it looks like this is just one window, but when you scroll, you will see all your other heights. Right here, log duration, this is what we're looking for. And when you put check marks here or uncheck them, what that does, it will limit the processing of the base unit, because you're going to download a base file that is actually longer in duration. It starts before and it ends after your Rover. But when you put a check mark in here, it will only process that base unit to start at the exact time of your Rover and the exact end time of the Rover. I would just recommend checking that. But now what we know is that I need to download the log file from September the 10th. This started at 18:08 hours, and I scroll down. I am in GPS time. So GPST, which is the same as UTC 0, Greenwich time, with a difference of about 18 seconds. So now I see I started at 18:08, I finished at 21:48. So what I'm going to do is I'm going to download the log file that goes from 1800 to 2200 GST. So now that's what I need. Just to quickly run down the options. This filter, this is how it processes the file. I need to get educated and understand when you would only want to do forward, backward, or combined. I do not know, and so I leave it on combined, and when we process it, you'll see that it might have a float result going forward, but then when it comes backward, it will be a fix. So I am going to put a link to the community forum, and listen, there are guys on the forum that they are so far beyond me. I enjoy doing these videos and trying to help new people out. I in no way am trying to say that I'm the master of the Emlid units and doing surveying and anything like that. There are guys that are so much more advanced than I am. I'm just bringing a video to help you learn, because I understand that trying to get started and understand some of this stuff can just make you want to pull your hair out. And once you get it, man, it is easy, and you can go out and do it. But it just takes a little while, if you've never done it, to just grasp all the concepts and know what you're doing. Elevation, this is the elevation mass. This is the degrees above the horizon where you cut off and say, do not use any of the satellite data that falls below that angle. And so the satellites are constantly rotating around the Earth. And then when they get down below 15 degrees, they're getting close to falling below the horizon. Well, there's a lot of interference the lower you get toward the horizon. And so the purpose of setting that mask is so that you don't have GPS, or I should say GNSS data, that is just too corrupt with interference. But you may also have a situation where, for whatever reason, you do not have enough satellites to get a fix. Well, you could lower this, maybe go down to 10 degrees. But with the 10 degrees, you're going to get maybe more satellites for the time frame you need, but you could also have more interference. So it's a kind of a catch-22, and you just sometimes have to play with it. Generally speaking, I leave it at 15 degrees. You can look up the signal-to-noise ratio mask. That has to do with the quality of your signal. There is a YouTube channel, and I'm just going to give a shout-out to him, Rami Tamimi. That dude I don't know him personally, and he certainly doesn't know me, but I love his channel. He has a good channel for guys that are new to surveying. So I actually used his channel a lot when I was trying to learn about the total station. And he has recently started doing videos on the Emlid products. And so he is wonderful in the way that he does his videos. I love his twin. That's always helping. But anyway, if you're new, you need to go to Rami's channel, and I'll put a link to that. And then go to the Emlid forum. There are many guys there that will help you out. There's a guy, Bide is one of them that's there. I better not call names, because there are many of them that are very helpful. Michael from Chasco down in Texas. Michael was very instrumental in helping me when I first started, and he is very involved with the Drone Deploy forum and also the Emlid forum. But there are many more guys and ladies that are on there that can help you out and answer questions. So you definitely want to spend time on the Emlid forum. All right, let's keep moving. Solution format. I'm working in the latitude, longitude, height. Your time format, again, GPST, I leave it in that. You can either do degrees, minutes, and seconds, or just decimal degrees. So that's going to be a personal preference. And that's it. So I'm going to save this. So we now know, real quick, let me go back. What was it? It was on the September the 10th, 1800 to 2200 GPST. Okay, so now let's switch over. I'm going to show you where to go find those files. Okay, so in the United States, this is where you would go to find all of the core stations that are all over the country. And man, look, I mean, again, when you zoom out, you begin to see where there are just many of them and where they're kind of sparse, but you still can use the core stations even in areas where they're just not as abundant. And I do know that Emlid is going to allow for additional bases. So you can pull in from, say, 2 or 3 bases instead of just one. There will be times when that would be beneficial, especially when you have a very long baseline. Such as up here in South Dakota. You can see they're much more sparse. Okay, and even like right down in this area, there's really not much. Okay, now when you know where you did your survey, so we come in to bear with me, I got to get back over to Memphis. Here we go. Okay, so I am right down in the South Haven area, south of Memphis, Tennessee. This project was over in Olive Branch. And so when I click on ZME1, which would have been the closest, I can say get site info. And this is where you can go and look. Actually, I'll show you. Right here it says data availability. Okay. Now, if I come up, and this is ZME1, oops. On the start date, this is going back, this was September the 10th. Actually, I'm going to do September the 17th, but I want to do it as 14 days. I think it'll do front and backwards. Okay. And I'm going to say get data availability. You can see that on this one day, in that little section right there, wouldn't you know it, there was no data available. I always use ZME1. And on that day, they decided to have a problem. So not sure what happened, but something did. So now I know that I have to use a different site. Now, Opus used Tennessee 43. Is that ZME1? Okay, where? Tennessee 43. So that's actually, a fair amount. So between this one, the one in Oxford, MSOX, and then this one, Opus also used ARWY, the one over here in Wynne, Arkansas. But for the sake of this test, I'm going to use Tennessee 43. So that's the one I want. I do know the data is available, but again, if you're trying to find a core station, you can click on it, go through the links, and see if it's available for the day you need it. So now I'm on this page, and you can see the address right there. So 9/10 is the date. 2021, it's the 253rd day of the year, so that matched up. And remember, we want to do 1800, and I want to do 4 hours to 2200. If it needed to be to, say, 22, 4.5 on my neck, I can go to 5, 6. It's going to be an even number of hours. But I'm going to do 4 hours. I want it to be UTC. I call it UT0. That's Greenwich time. So UTC 0, as I'm calling it, is what I want to go off of. And 4 hours sampling. Now, I'm only going to download GPS because I'm going to compare this to the Opus data, and Opus only uses GPS. Okay? So if you want to use Opus, they're only going to use GPS. Now I'm going to select Get Cores Data. And we are now at the folder for my base. So I'm going to go to there. Now I have the Tennessee. Matter of fact, we're just going to overwrite this file. So I'm going to hit save. It's going to say, do you already have it? Yes, we want to replace it. All right, I'm going to go into the base, and let's just delete this one. Delete it. And let's unzip 7-zip, my favorite extractor. Extract files. All right, so here's Tennessee 43, and here are the 3 files. So I'm going to move this out of the way, and we're going to switch back over to Emlid Studio, and let's go ahead and bring this in. Okay, now this is the base unit, so this is our cores, and again, what it wants is you can do any of these file formats, but this is in Rhinex. So I'm going to bring in the O, observation, bring that in here. And again, what it did is it pulled the location information from what is considered the Rhinex header. So everything is in there. You don't have to make any changes. And you can use either the core station navigation file or the RS unit observation file. It makes no difference. But since this one's open, I'm going to go ahead and drag that into the observation. I'm sorry, I messed up. Boop. Okay. Well, at least it'll tell you when you mess up. Okay. N for navigation. So N for navigation coming down here. Now I'm going to close this. Okay, so one thing I need to point out real quick is that I'm about to make a boo-boo because when you're doing a static point, a RS unit over either a known point or a point that you're going to create as a benchmark, you don't want to have this set to kinematic. That is incorrect. So this needs to be set to static. Now we have our RS2 base unit, which again, it's in the Rover section because it's what's being corrected. Here's the cores station, which is the base. Now I'm going to click on process, and this is going to go frontwards. Then it's going to, when it gets all the way to the end, it's going to come backwards. And once I know and fully understand if there is a specific situation where you should only do one or the other, then I'll come back and either put it in the notes or do a very short video to explain that. But we're going to skip through this and we'll be back in just a second. All right, this is about to be completed. Now, this is the folder for the Rhinex files that came from the RS2 base unit. And you're going to see that when it's fixed, it's going to add a few additional files in here, and I'll show you what those are. Now, also, let me drag this off screen. Your fixed point will show up dead center. Now, right here, these are the two files. There were really no events. When we're dealing with the drone data, we'll definitely have events. But then here, this is your position file. This is the post-process position. So we'll look at that in just a second. So this little green dot represents the fixed point. Right now we're at a zoom level that is 5 millimeters from each square, represents 5 millimeters. So if I click on the green dot, there's your location. And I will tell you, I can click on it and get the post-process location. This is in decimal degrees, not degrees, minutes, and seconds. So if I click on this to copy, it copied it to the clipboard. Hopefully, Emlid will fix it to where this is actually displaying the same format that I have right here, which is degrees, minutes, and seconds. It would reason that that's what you want, that it would show up here. In order for us to see our post-processed location, I'm just going to open up this file, and I'm going to use Notepad++. Here we go. This is our PPK latitude, longitude, and ellipsoid height. Now, what I want to do is I'm going to show you, I'm going to pause this and be right back. I need to find the Opus file, and I'm going to show you what the Opus results were so that you can see that. All right, so here we are with the Opus results, and I'd sent this in back on December the 27th. Down at the bottom of this file, it tells me that they use Tennessee 43, which is the same one we use, and they also use the core station in Wynne, Arkansas, ARWY. But what I want to show you is how we compare. So for latitude, it was at 49,12669, and we're at 12764. When you were looking at the seconds, if this was 00.00101, that is equal to 1/64th of an inch. So if we're looking at the US measurements, so that's a 64th of an inch. That is very small. And matter of fact, we're at 669 and 764. So we are close to a 64th of an inch for our processing. Now we come over to longitude. We're at 44.25574 and 24279. We are at 3/64 there, and then in a millimeter, I don't know, what is that, 2 millimeters, something like that, 2 to 3 millimeters. I mean, we're spot on, and our ellipsoid height 78.032 and 78.039. Bottom line is, it is spot on. So very good. And you know what? It is free, absolutely free. So I'm going to close this, close that. All right, so we have finished the processing for the base unit, and it is now time to take that base and use it to process our rover. But you know what? Before we go there, I want y'all to meet Minnie. This is my sidekick. Now, I have my wife and 2 kids who I love dearly, but this is my little sidekick, Minnie. She is a miniature Australian Shepherd, and she is a little over two 2 years old, I think, or maybe 2.5. But anyway, I love this girl. She goes with me, does droning, and just she loves to ride. But anyway, all right, we got to get back to work. Say bye, Minnie. Okay, so let's go back to desktop. Okay, so we are now ready to take the base that we've just processed, and we're now going to process the rover using the PPK base data. So let's open up that folder. There it is. And I'm gonna bring in my base information, go into my Rhinex folder, and okay, so one thing that it's easy to miss, especially when you're switching back and forth, and then you have to just rerun it again. I don't know if Emily can make it to where it's either easier to not miss it or some kind of checkpoint. But we are now, since we're working with a rover, we have to do the stop and go with Reach View 3. And again, in a future, maybe the final release, they will have stop and go with the Reach panel. Might be another option. So I think that is going to be added in. But bottom line is, we have to select this one. And then you also want to make sure it is on kinematic, not static, because we're going to be moving around. So now that we've selected these two settings, I'm ready to drag in my files. So for the base, I want to bring in the observation file. And when I bring that in, it is going to show you the Rhinex header position. This position is the coordinates that were written into the Rhinex header out in the field. It is not going to be accurate. So what we need to do is we are going to use the PPK coordinates. Again, one option that I hope will be available in the future will be that Emlid Studio will recognize if there is a position file and it only has 1 point, which means it is from a static observation. As we see here, just the 1 point, and here's the PPK data, that it'll actually read that and populate the information here once we switch over to the manual entry. So if you do not want to use the Rhinex header position, in which we never will if we're using our RS2 base, we're going to switch over, and in this case, I'm going to do degrees, minutes, and seconds. Now, one thing I'll point out, when you enter data, I've zeroed this out, but once you start using Studio, when you do one job and then later you go to process another job and you switch from Rhinex header to, say, the lat long in degrees, minutes, and seconds, whatever value you put in this field previously, it's just going to stay there. It's not auto-populating it from your position file or anything else. So you have to be aware of that. In my opinion, Emlid should either zero this out every time, or at least give you an option to zero it out, or if it's going to auto-populate, that it would read the position file and pull it from that file. So we'll see what the future holds for that. But for the meantime, we are going to get this entered in. So what I did is I highlighted all of it and I hit delete. So now our latitude is going to be 0345549127764. Now we're going to go Control A, delete. You have to be careful. You can inadvertently leave the plus or minus. So there are four sections, four spaces here. You got to be sure, and if you're in the States, I mean, we got to be negative, like I'm negative 89, so for east. So be sure you don't miss your plus or minus mark. Minus 089, 49, 44.24279. And the reason I say that, because you can, well, it won't process if you miss it. All right, 78.039, and that's going to be it. Now let's bring in our go to our, actually, while we're here, navigation, as you'll remember, we can use the navigation from either the base or the rover. I already have this one open, so I'll bring in the the navigation file from the base, drag it there, okay? Now we're ready to switch over to our rover, go up into the Rhinex section. Now for our rover, I'm going to bring in the observation file. So when you go in, you will only have these 3 files, okay? So I'm going to bring in the observation file here. It's telling you right here, the antenna height will be taken from the CSV file. What it's referring to is this CSV file, which is the file that I exported off of the device that was used when I did the survey. So again, the ReachView 3, the survey is saved in a file on the device that you use while you're doing the survey. A ReachView panel survey, the CSV file is saved on the RS unit itself. So if I try to drag this down here, you see it won't let you drag it because we have to process it first. So I'm going to click on process and it'll go through. This should go pretty quickly, so I'm not going to pause the video. When it comes back, we will then be able to drag the CSV file over and then display the PPK or corrected points from the rover. So we'll give it just 1 second and it'll be ready. We can see the points that are really not fixed yet. It's saying project from ReachView 3, which is the CSV file. So let's open this. Now I can drag that over, put it right here. You can display your different solutions. Well, I only want to see my fix solutions. If you wanted to see all of them, you can select fix and float. So I'm going to hit start. And there it is. So there are, oops, and there's one and the one down. Okay. Now, you see where those points are, and just to remind you, do I still have, well, I was going to show you the Google Earth. I don't have it open, but this is the same points that I showed you on Google Earth when we started the video. So this was down at the entrance. This is right here behind the church. This is over in the back of the parking lot, over on the south end of the parking lot, and all the way in the south end, there was a restaurant right here. So that's it. And so now I can say show results file. It'll open this up, and this is in the Rhinex folder, but it actually puts the file and it says corrected. So this is the file that you will then use to do your ground control points. If you're doing aerial mapping, then you'll use this data to put your ground control points into whatever photogrammetry software you're using. And so there it all is, everything you need. Well, okay, I hope this was very helpful. I know that my videos tend to go longer than I want, but I just know that there's questions. People start out, they're trying to figure out the software, and so I guess I would rather err on the side of providing extra detail than just skipping through it 90 to nothing. Certainly there's other videos out there to talk about this stuff, and so I want to try to help you learn. This was specifically for doing a base and rover setup. So the next video that I do will be doing the drone PPK processing. And so we'll take a look at that. I'm definitely going to do the Emlid. I have an M Plus in a kit that goes on the Phantom 4 Pro. So I'll be able to take the Phantom 4 Pro and put the Emlid on there and use that and process the data using Emlid Studio. I have asked somebody if they can give me a data set for the Phantom 4 RTK, and then I would, if I get that in time, then I can just include that in the video and do both. There's probably going to be a little bit of differences. I don't own the Phantom 4 RTK, so I'm not exactly sure how that will be processed, but I'll get the images and the GPS, GNSS log files and see what we can do with that. What else? So when I started out the video, I mentioned that this was mapping affinity. Well, it is going to be the last and final name change because I had Mid-South 360, which was my company name going way back. And then I actually changed the YouTube channel to Mid-South Drone Services. But the fact is, these videos don't have anything to do with my business. They're about drones, but they're in drone mapping, but it's really just teaching. I enjoy doing videos where I share the struggles and just to be able to share it with people to make it easier, but it has nothing to do with my business. And so I want the name of the channel to better reflect that. And so I think Mapping Affinity will be the name. So we'll see. I've kind of playing around with a few other names, but just using the affinity on the end, because that just represents that we are all in this because we like the drone mapping. We're trying to learn, and not just when I say drone mapping, aerial mapping, be it photogrammetry or LiDAR, maybe even thermal comes into play a little bit. But you know what? LiDAR has grown a lot in the last half of 2021. This year, this is going to be the year of LiDAR. I mean, it is just it's growing. But photogrammetry will not disappear. Photogrammetry is here to stay. There are times when photogrammetry works perfectly fine. You don't even need LiDAR. But until they have LiDAR systems out that are just fully integrated with LiDAR and the camera, if you want to colorize your LiDAR cloud, you have to run a photogrammetry mission. Now, it can be a low res mission, but you still have to run that. So photogrammetry is still here. It's going to be a very viable product for many years to come. So anyway, we've got a lot of good stuff coming down the pipe. If this was helpful, give me a thumbs up. And if you have suggestions, if you have questions, then put them down in the comments below. And as we move forward, I don't know if having a website that kind of correlates with, say, mappingaffinity.com, and there's a place for people to post questions. And then if I don't know the answers, I try to do a referral to somebody else or a forum that might be helpful. But this is for me to help you, and then hopefully you guys to even help each other and help me. So this can kind of be a community project, and just we'll see where it goes. But anyway, thank you for watching. I'll see you in the next video.